This is Geometry Section 10.6 on tangents, secants, and angle measures. And the first thing we're going to look at is a secant. And this blue line would be an example of a secant. Basically, a secant is a line that contains a chord. So I highlighted in green that chord that it does contain. This purple line is another example of a secant. And if two secants are going to intersect, they would intersect outside of the circle. And what we're going to be focusing on in this section is how do you find the angle measurement for this angle formed by the intersection of two secants, or we could find the angle formed between a tangent and a secant, which would again be this angle on the outside. And the other kind of objects we could have intersect would be if we have this chord and this second chord intersecting inside the circle, we have a formula to figure out that angle measurement as well. To start off with, we're going to look at these angles. The first one, we have two intersecting secants. They're intersecting outside of the circle. And the way we're going to find x is we're going to take the measurement of this big intercepted arc, which is 90 degrees. And we're going to subtract away from it this arc on the near side, this near intercepted arc. And then divide that by 2. 90 minus 40 is 50. 50 divided by 2 is 25. So x equals 25. Next one, again, our angle is outside of the circle. It's formed by the intersection of this tangent and also this secant. So we're going to take the big intercepted arc, the one on the opposite side of the circle, which is 170, and we're going to subtract the intercepted arc on the near side of the circle, which is just this green part that I've highlighted. We have 170 plus 120, that's 290 degrees. So that means that there's 70 degrees left for this angle. So we're going to take this big 170 minus that 70 divided by 2 to get that z equals 50. This time we have two intersecting tangents. Once again, it's going to be the big arc angle, in this case that's 200, minus the small arc angle. So to find the small one, I'm going to take 360 minus that 200, which will leave us with 160. We take that difference and divide it by 2, so that means that in this case y is going to be equal to 20. Whenever the angle formed by the intersecting lines is outside the circle, we take the big arc minus the small intercepted arc and divide it by 2. If we have angles formed by intersecting chords, the formula is different. For example, we have this green chord and also this purple chord intersecting at that point, and I want to know what is the measurement of that angle. Let's just say that this angle is 95 degrees and this angle is 85 degrees. If I were to subtract those, 95 minus 85, I get 10. 10 divided by 2 is 5, and that angle does not look like it's 5 degrees. And in fact, since these intersecting chords give us this intersecting angle, or this angle of intersection, we don't subtract, we actually add. We find the average of those two intercepted arcs. So 95 plus 85 divided by 2 gives us that x in this case is equal to 90. So when the angle is outside, we subtract and divide by 2. When the angle is inside, we add them and divide by 2, or we just find their average. We'll go through a few examples of using that formula. To find this x, we would take 95 plus 55 divided by 2. And that's going to give us that x is equal to 75. This one's a little bit different because the unknown is the arc angle on the upper left-hand side. So the formula would be y plus 95 divided by 2. That's equal to the angle on the inside, which is 110. Multiply both sides of this equation by 2, so then y plus 95 equals 220. Lastly, subtract 95 from both sides, and we'll get an answer of 125. This problem has a few additional steps to it. I have this 60-degree arc angle and this 30-degree arc angle, and if I were to look at this chord as well as this second chord, they do intersect. 60 and 30 averaged together will give us this E. 60 plus 30 is 90. 90 divided by 2 is 45, so E is 45. And if E is 45, subtract that from 180, and then I get that D is 135. The only other unknown we need is C. To find C, we notice that it's the intersection of these two tangents. here is the big arc angle. That would be an unknown at this point. And then here is the small arc angle, and that's 140 degrees. Well, if this small turquoise arc angle is 140, I can take 360 minus that, and that would tell me that this yellow arc angle then is 220 degrees. So to find C, it is 220 minus 140 divided by 2, and that's equal to C. 220 minus 140 is 80. 80 divided by 2 is 40. So C is equal to 40. Those are the three angles in this problem. Here's another problem dealing with intersecting secants. The secants intersect outside the circle, and this time we have some concentric circles. If I took y minus 40 divided by 2, that would be equal to x. The only problem is I have two unknowns in that equation, so I'll put that to the side for right now. The other formula that we could use is 130 minus 72 divided by 2, and then that would be equal to x. So that can tell us actually how big x is equal to. 130 minus 72 divided by 2 is 29. So there's one of our variables. X equals 29. And if I plug 29 in for x in the other equation and start solving this one, I can find out my y value. Multiply by 2, multiply by 2. Y minus 40 equals 58. Add 40 to both sides, and I get that y equals 98. Here's the last problem in this section. Based on the numbers we're given in this problem, we can fill in certain known pieces in this one. And we're asked to find the measurement of arc angle TA. Since this big arc angle is 118 and this smaller arc angle is 72, we can take 118 minus 72 and get 46 degrees for that arc angle. And the reason we know it's an arc angle rather than an arc length is because of that M out in front. The next thing we're asked for is measure of angle PTN. Since arc angle TN is 118 degrees, it means that this central angle is also 118 degrees by definition. And then looking at this triangle, we know it's an isosceles triangle because it has two radii of the circle. There's 180 degrees inside of that circle, so 180 minus 18 is 62. So there's 31 degrees to split evenly between those two angles. And we now know that measure of angle PTN equals 31 degrees. The next unknown is measure of arc angle ND. This is 118 degrees. Here is arc ND. We're told that TD is a diameter, so if we took 180 minus 118, we get 62 degrees for measure of arc angle ND. Next up, measure of angle AED. This is an inscribed angle. And there is the intercepted arc. We know that from A to N we have 72 degrees. Now we know from N to D we have another 62 degrees. So when we add those together, that means that this big yellow intercepted arc is 134 degrees. And to go from intercepted arc to inscribed angle, we divide by 2. So from here to this angle, we're going to end up with a 67 degree angle. Next, we're asked to find the measurement of arc angle TE. We don't have a direct way to find this right now. However, we'll focus on these two intersecting secants. And since that intersected angle is outside of the circle, that means we're going to take the big arc angle, measure of arc angle TE, minus the small angle, which is 18 degrees, divided by 2, and that's equal to the angle on the outside of 26 degrees. If we solve this equation, we'll multiply both sides by 2. So measure of arc angle TE minus 18 is equal to 52. Add 18 to both sides, and we get that the measure of arc angle TE is 70 degrees. Next, we want to find the measure of arc angle ER. And if we look at what we already know, this angle is 70 degrees, this angle down here is 18 degrees, and ER completes the semicircle. So we're going to take 180 minus 70 minus 18, and we have 92 degrees for measure of arc angle ER. The last one we need is the measure of arc angle ANR. So ANR starts at A, passes through N, and ends up at the letter R. If we add up all those together, that's 72 plus 62 plus 18. That would be 152 degrees.